Imagine the research and development cost of an airplane surpassing £10 billion. One of the most revolutionary aspects of its design is the massive wings, which belong to the world's largest passenger aircraft, the A380, designed and manufactured at Airbus's largest factory in the UK. This factory, located in Broughton, has ramped up production from 4 to 6 wings per month. Nestled among farmland in North Wales, this colossal factory employs over 6,000 people, making it the largest factory in the UK. The factory manager, Paul McKinley, inspects the factory daily, ensuring everything is going smoothly. Established in 2003, the A380 factory is the largest factory built in the UK in over 20 years. For the technicians, it's more than a workplace. It feels like home. The Airbus A380 Super Jumbo passenger aircraft made its debut in 2007. Developing this behemoth came with an estimated cost of around £10 billion. Constructing such a massive aircraft was an extraordinarily challenging feat, with numerous failed attempts throughout aviation history. Like all large jet airliners, the A380 is assembled in sections, with the fuselage, nose, and tail manufactured in various factories across Europe. The most significant technological innovation, however, is its colossal wings, which are manufactured at a factory in the UK. Airbus chose Broughton, with its 70-year history of wing manufacturing, to produce the A380's wings. The factory aims to increase wing production from 4 to 6 per month without increasing the workforce, ensuring they can consistently meet the growing demand for orders. The wing manufacturing process starts with a vast array of raw materials from around the world. The 33-meter-long aluminum material is sent to the factory's sheet molding area. Due to the immense size of everything on the wing, these aluminum materials are placed on Europe's largest milling machine. First, the aluminum is polished, and after 72 hours, it is carved with various intricate patterns. Waste materials generated are collected and recycled. Next, the flawlessly polished panels are crafted into aerodynamic contours, as per the designer's specifications, and placed on specially cast machine tool beds. The panels then move on to the oven, where they are heated to 160 degrees Celsius to set their shape. The A380's wings are critical in lifting the 500-ton Super Jumbo to an altitude of 12,000 meters. The wing's shape features a curved top surface and a relatively flat bottom surface, causing air to flow faster over the top than the bottom, lifting the wing and the fuselage into the air. Furthermore, the wings contribute to the aircraft's fuel efficiency, with each passenger's fuel consumption being lower than that of a family car. After heat treatment, the massive panels undergo 12 baths for cleaning and protection, with surface treatment equipment running non-stop 24 hours a day. The next step is the assembly of the wings. With roughly 4 million parts in the A380, nearly 500,000 of those are on the wings alone. The wings house various technical systems and carry most of the fuel, including a complex fuel tank and fuel pump system. The wiring and pipeline span 37 kilometers, powering all flight control surfaces. Additionally, the wings support 4 enormous engines, each weighing 6 tons, as well as the landing gear, which can withstand a weight of 560 tons and landing speeds faster than Formula One race cars. The wing assembly workshop resembles a giant mechanical package, with rows of parts at the ready. To complete the assembly, each wing requires an enormous assembly jig, the largest in aviation history. The lifting team begins their work. First, the rear spar is hoisted, with 3 long components forming the backbone of the wing. They are securely fixed on 45 positioning pins. Over the next 5 days, the installation team will install all 49 ribs spanning the wing within the assembly jig. These ribs, made of aluminum and carbon fiber composite materials, are known for their strength and lightness. When the wing frame assembly is complete, the skeleton is covered with massive aluminum panels, which serve as its skin. Enormous automated machines drill up to 250,000 holes per wing in the panels. After 25 days, the main body of the wing is finished and removed from the assembly jig. At this point, it weighs close to 30 tons, and when lying on its side, is as tall as a 4-story building, posing a tremendous challenge for the lifting team. The sturdiest part of the wing, where the engines are supported, features titanium brackets that bear the entire weight of the wing during the lifting process. Technicians remove all support brackets one by one and release the wing from its anchored state. After double-checking that all positioning pins have been removed, the crane lifts the nearly 30-ton wing. Only at this moment can one truly appreciate the enormity of the A380. Its horizontal stabilizer is larger than the wings of an A320 and 50% larger than the wings of large jet airliners. This super jumbo could fill Wembley Stadium, with wings spanning 10 meters wider than a football field and boasting a wing area exceeding 400 square meters. However, compared to other commercial aircraft currently in operation, it is the most efficient and produces the least noise. Once the crane lifts the wing to the designated position, it is carefully placed on the fixed support. The handcrafted wing's shape must then be checked for standardization. Lasers are used to shine into the 3 mirror surfaces of corner cube reflectors, which reflect back and provide all the wing's measurement data to ensure aerodynamic compliance during flight. The wing's shape, a result of meticulous design, possesses unique aerodynamic characteristics that significantly enhance its flight efficiency. Broughton has a long aviation history. During World War II, the Wellington bomber was produced here, achieving a production rate of 1 per day. However, another Airbus factory in the UK has an even longer history. Located near Bristol, the Filton factory has been producing aircraft for over 100 years and is globally renowned for developing the Concorde. Design and testing take place in a specialized laboratory where all Airbus wings are designed and tested. Engineers must inspect every bolt, washer, and rivet. Although the A380 is in production, the design team is constantly seeking improvements. In a special facility at the Filton factory, engineers conduct a series of tests on a lighter new landing gear. All the pipework and wiring here are identical to a real aircraft, with parts of the landing gear system installed in the wings. The test rig, just like the actual system, can retract and extend the A380's 22 large wheels. Despite the aircraft being in service for many years, safety checks continue, and each minor design change means the entire system must be thoroughly retested. The A380 has 16 brake wheels, with 4 on the fuselage landing gear and 4 on the wing landing gear. They are currently developing a new brake to reduce the weight of the brakes and wheels, saving the equivalent weight of a passenger. Saving tens of kilograms from hundreds of tons may seem negligible, but over more than 20,000 flights, it can add up to significant fuel savings. Today, an emergency free-fall test will be conducted. In the design, the landing gear can push open the doors and fall into place solely with its own weight. However, with the new brakes, the landing gear is lighter, making retesting particularly crucial. With the goal of proving the strength of the Super Jumbo and its wings, over £100 million was invested in building the largest testing equipment in history. These devices aim to reveal potential weaknesses in aircraft structural design, simulating problems encountered in flight, and subjecting them to repeated stress tests. All tests demonstrate wing structural strength. Computer systems drive 180 hydraulic heads to continuously bend and twist the wings, simulating turbulence or landing situations a real aircraft might face. Precise engineering ensures the wings bend correctly. The ribs and spars are strong and moderately flexible, capable of withstanding tremendous pressure. This is the most critical test for the entire project, aiming to prove the aircraft's ability to safely navigate. After 5 years of continuous 24-hour stress testing, they finally concluded that the aircraft would operate for approximately 25 years. However, their tests simulated an equivalent of 65 years of flight time. An extraordinary accomplishment. Back at the wing manufacturing factory, the installation of the flight system is approaching, but before that, a crucial safety test must be conducted. In addition to providing lift and control, the wings also serve as the A380's fuel tanks. Sealed wing ribs separate each fuel tank. Technicians must test these ribs to ensure they are watertight. First, the fuel tank is sealed, and high-pressure air is pumped into it. They must crawl inside the tank to closely observe the ribs and apply a solution to the seals. If there is a leak, bubbles will appear. After completing the internal inspection, the wing surface is checked for leaks. This time, the wing tanks are filled with helium, and sensors detect any leaks. After checking all fuel tanks, this wing is ready to have all the systems required for flight installed, including the hydraulic control system's lines, pipes, and conduits, as well as the fuel system. This stage requires 200 technicians and 22 days to complete. Today, a fuel system expert visits the factory to find ways to speed up manufacturing. By observing the installation process of the engine feed pumps, She can design improvements for the entire installation process. Due to its immense size, the A380 requires a new fuel system. Each wing can hold 118 tons of fuel, and conventional fuel systems would put enormous stress on them due to their weight. Designers created a dynamic system that continually distributes fuel from 11 independent tanks, distributing the weight optimally. On the ground, fuel is concentrated in the center of the aircraft to prevent the wings from bending too much. During flight, fuel is pumped towards the wingtips to prevent the wings from bending upwards. The tail also has a fuel tank, which sends fuel forward during flight to maintain the aircraft's center of gravity. This lightweight fuel system makes the A380 the most fuel-efficient passenger aircraft. However, the aircraft's large size means that flight preparation times are long, which can cause losses for airlines. Therefore, a highly complex refueling system was designed for the A380, which can fully refuel the aircraft in just 45 minutes. Airlines always want to reduce fuel costs, so fuel efficiency remains a constant competitive theme. Although the A380's wings already have the highest fuel efficiency, Airbus is still improving the design to make them even lighter. For example, by reducing the thickness of the belly panel by 1 mil, each wing could potentially weigh 350 kilograms less, saving millions of pounds over the aircraft's lifetime. The first wing incorporating all weight reduction measures is about to roll off the production line, and the team needs to verify whether the weight reduction meets expectations. They use a 20-ton weighing sensor, with 4 used in each weighing. The crane arm lifts the wing using 4 small pedestals, and the computer makes predictions and calculations. According to the calculations, the wing weighs 350 kilograms less than before. The efforts of hundreds of people over 2 years have been validated, and future wings will be lighter and more environmentally friendly while maintaining their strength. Back in the factory, once the wing assembly is completed, each wing is wrapped in heat-shrink plastic. The wings will arrive in Toulouse, France, in 28 days to be assembled with the rest of the aircraft. The first leg of the journey is via waterways, but the barge is nearly 2 kilometers away, so it must be transported using a 39-meter-long trailer. Only one wing can be transported at a time, with special care taken to avoid any bumps. An hour later, it heads down the River Dee towards the coast, where the 2 wings are loaded onto a specially designed ferry bound for France. Meanwhile, the fuselage components have also set off from Germany. In Spain, the tail section is loaded onto the Beluga transport aircraft, a custom-built transporter for Airbus. 2 weeks later, the wings arrive at the French port and are then towed to their final destination by trailers. At this point, all major components of the aircraft have convened, and a brand new A380 is about to be born. That's the end of today's video. I hope you enjoyed it. Don't forget to subscribe to our channel so you won't miss our future content, and I'll see you in the next one.